For those of you who are new to Python and data science, this next section is a crash course in Python 3 and some of the libraries data scientists commonly use with Python, including NumPy, Pandas, Matplotlib, and Seaborn. If you're already familiar with these tools, you can just skip this section and move on to the next one. But if you're new to Python or the specific data processing and visualization libraries that we use in this field, continue onward. Obviously, I can't teach you how to code in one little section of this course. It's okay to be new to Python as it's pretty easy to pick up, but you will need some prior programming experience to understand what's going on here. If you're totally new to programming in general, I'd encourage you to take a larger Introduction to Python course first before returning to this one. If you just need a refresher in Python and the data science tools used with it, though, let's get you up to speed in the next few videos. So let's do a little quick crash course in the Python programming language here. To do that, we're going to open up another Python Jupyter notebook to play around with, just to introduce some of the main features of the language. So if you don't already have it opened up, go to Anaconda and open up your Anaconda prompt. CD to where you install the course materials, wherever that may be. And type in Jupyter with a Y, notebook. And up should come your web browser with a list of all the course sections. Let's go into section 3. And under section 3, let's open up the Python 101.ipynb file. And that's our Python crash course. So again, I'm assuming that you've done some programming before, and maybe you're just new to Python or you need a refresher about what's unique about the Python language. So I am not going to teach you how to program here or what the fundamentals of computer science are. I'm assuming you already know about programming in general, and you just want to know what's weird about Python, okay? If you are new to programming in general, probably be a really good idea to go back and take an introductory Python course first, and then come back here. But for a quick refresher here, let's just talk about what's weird about Python. So kind of the weirdest thing is that whitespace is really important in the Python programming language. Let's take a look at this little block of code here. What we're doing here is creating a list of numbers that contains the numbers 1, 2, 3, 4, 5, and 6, iterating through every number in that list, and if it's even, we print out that it's even, otherwise we print out that it's odd, and when we're done, we print all done. So in other languages, you might expect there to be a curly bracket or some sort of other syntactical indication that says I'm within this for block, or that I'm within this if block, or that I'm within this else block. But in Python, it doesn't work that way. The indentation, the actual number of spaces and tabs, is what matters. So you see here we have list of numbers that's not indented at all. That means that that's at sort of the topmost level. Then we have this for loop with a colon at the end. And following that colon, we have an indentation here for the next line. And that indentation is what indicates that this code is part of this for loop, nothing else. We have this if clause here, which also has a colon, and everything that's indented after that colon is going to be part of that if block as well. Same thing here, we have an else followed by a colon. Everything indented further beyond that colon is going to be part of that else block. There's nothing else to signify that the block is finished when you're done. It's just the spacing that matters. Now that we're clicked inside this, let's hit Shift-Enter to run it. And you can see that it does in fact run. Just as a sanity check to show you that the notebook is in fact doing something interesting, I can add some more numbers to this list and run it again. Let's say comma 7, comma 8. And Shift-Enter, and you can see now that we have 7 and 8 added to the output as well. So this notebook really is executing within this Jupyter Notebook environment within your web browser. Jupyter Notebooks are pretty cool things. You can not only use them for prototyping and sort of playing around with stuff and sharing your notes with people and embellishing your code with comments and stuff like that. People have also integrated them into real production systems. So, for example, Amazon has a system where they can run their entire recommendation engine right from a notebook on this huge cluster of computers that runs on millions of people. So it's not just for experimenting and prototyping. You can actually use these for real as well. Next, let's talk about importing modules. So just like we have libraries in other languages, we have what we call modules or packages in Python that import code from pre-written packages of code that already exist. So we don't want to have to rewrite all the basics of statistical processing, for example. There's a handy-dandy package called NumPy that's part of Anaconda that we can use instead. So to use that code that exists in the NumPy package, we can just say import NumPy. That says import the NumPy package, and then as np means that we can refer to that package as np just to save us some keystrokes, to save your fingers a little bit of work there. So then we can use that package like this. We're going to say an array called a is equal to np, that refers to the NumPy package, dot random random.normal. So this is using the random.normal function that's within the NumPy package. We're going to pass it our parameters here. That means that we want 10 random numbers generated around a mean of 25 and a standard deviation of 5, and then we'll print out the resulting array. Shift-Enter, and you can see that we did in fact get a fresh set of numbers here that are more or less around 25 plus or minus 5 or so. So that actually worked. So that's how importing modules work. Usually the first thing you'll see in a Python notebook is all the imports. So all the different packages that we want to use in this notebook need to be declared up front before we can actually use them. Let's go into data structures a bit. So in other languages, you might hear about arrays. In Python, they're called lists. Same idea. So here we have a list called X that contains the numbers 1, 2, 3, 4, 5, and 6. A list is declared with these square brackets, followed by a list of stuff separated by commas. So pretty straightforward stuff. We can then print out the length of that array, how many elements are in it, using the len operator. Let's see that in action. Indeed, the length of the X list is 6. It contains 1, 2, 3, 4, 5, 6 things. So hey, that works. There are also some weird syntactical tricks for slicing and dicing lists within Python. For example, if I want to get just the first 3 elements of that list, I can say x square bracket colon 3 square bracket. And that colon 3 means give me the first 3 elements of that list. And indeed, that's what it gives us back. The values 1, 2, 3 in its own list. So we've created sort of a sublist of that original list with x colon 3. And a little bit of a note about how notebooks work. If you don't actually assign the result of an operation to a variable, it will just print out the result as part of the notebook. So by just saying x colon 3, that actually generated a new list that contains the values 1, 2, and 3, but we didn't put it anywhere, so it just printed it out. Basically, a notebook will print out whatever the last line in that block is for you automatically. And we can also say 3 colon. What that does is say give me everything after the first 3 values. So that gives me back 4, 5, 6 because that's everything after the first 3 values of the list. So we created a list that's everything after a given point. We can also say I want the last 2 items in the list. We can use the negative sign for that. So x bracket negative 2 colon means that I want the last 2 values in the list. So the negative 2 means go back 2, and the colon at the end means I want stuff beyond that point. That gives me back the values 5 and 6, which is the last 2 values of the list. Let's say we want to add a list to another list. We can use the extend function for that. So we're saying x.extend, and then we're passing in another list that contains the values 7 and 8. So we want to stick this list onto the end of the existing x list. As you recall, x contains 1, 2, 3, 4, 5, 6. And we're extending that with another list that contains 7 and 8. And we will print out x to give our final resulting list of 1, 2, 3, 4, 5, 6, 7, 8. So that just combines 2 lists together. That's what extend does. Sometimes you just want to append a single value to a list, and that's what the append function does. So I can say x.append 9. That will just append the value 9 to that list. And you can see that works as expected as well. So now the x list contains 1, 2, 3, 4, 5, 6, 7, 8, 9. Because not only did I extend it with the 7, 8 list, I also appended the value 9 at the end as well. It's also important to realize that lists don't have to contain individual values. Lists can contain pretty much anything. We can even have a list that contains other lists. So let's try that out here. Let's create another list called y, and that can contain the numbers 10, 11, and 12. I can then create a list of lists that contains the x list and the y list together in a list of its own. And let's see what that looks like. So look at what's going on here. We have a set of brackets here defining the list itself, the list of lists, and within that list we have 2 different lists. So we have another set of brackets here defining the x list here that contains the values 1, 2, 3, 4, 5, 6, 7, 8, 9, comma, and then the other list, y, which contains 10, 11, 12. So we don't have like one big list here. We have 2 different lists, and we have a list of those 2 lists. So you can kind of get all meta there if you want to. Referencing an individual value within a list is very straightforward. It works exactly the way you think it would. I can just say bracket and the element that I want. So y bracket 1 returns the number 11. Now we do start counting at 0, as we do in many other languages. So y1 actually refers to the second element of the y list. So I didn't get back the value 10, which is the first element. I got the value 11, which is the second element. Now if I wanted to get that value 10, I would say y0. And that would give me 10, the first element of the list. So remember, we always start counting from 0 when we're dealing with lists in Python. That can be a little bit confusing to some people. You can also sort a list. That's very straightforward. Let's set up a new list called Z that contains the numbers 3, 2, and 1. We can then sort it with the sort operation, print it out, and it does exactly what you would expect. It takes that list and sorts it in place, transforming our 3, 2, 1 list into a new list that contains 1, 2, and 3 instead. You can also sort in reverse order if you wish. You can just pass in the reverse equals true into the parameters for sort, and that will flip it around to what it was before with 3, 2, 1. Little syntactical note here: when you're dealing with functions such as sort, you can either pass in a list of function arguments like you would in most other languages, or you can also refer to arguments by their name, and that's what we're doing here. We're saying that we only want to specify true for the reverse parameter to the sort function, and that's what reverse equals true means. There's probably other parameters in there as well that we're just leaving at the default values, but we only want to specify the reverse parameter here, which we are setting to true in this case.